Hello, and welcome to Point Slope Form. Our objectives for today are to graph a line and write a linear equation using point slope form, and we're going to be writing linear equations given 2 points. So when we're learning point slope form, the first thing we should know is the point slope formula. So the point slope form formula is y minus y1 equals m times x minus x1. Now you should be familiar with m by this point because m is going to stand for our slope. And our x1 and our y1, those are just going to be points on our line. Now we're usually given this information and sometimes we have to go find it, maybe looking on a graph or reading the directions in a problem. But these points on the line are going to be very important for us to figure out what the equation of the line is going to be. So for example, let's say that you are given a slope of 2 and you are given the point 3, 4. And you're given this point and you're told to use this information to write the equation of a line. Well, we can use point slope form to write that. So we're going to have our y minus our y1, which here is 4, is going to be equal to our slope, which I defined as 2. We'll have an open parentheses, x, and then our minus our x1, which is 3. And that is the simplified version of point slope form. And you'd have several things you can do. Right from there you can graph it because you know 2 points and you know the slope. And we'll talk more about simplifying this in the slope-intercept form later on in the lesson. So in this example, we're given the slope to a line and a point that that line goes through. So our slope is -4, and our point is 6, -2. So we can use our point slope form to help us write the equation of a line. Now, for this example, I'm going to start off writing it in point slope form, and then I'm going to simplify it into slope-intercept form. So, as I fill in my information, I'm going to have y plus 2. My m is going to be -4, and my x is going to be 6. Now this is point slope form, and if I wanted to get it in slope-intercept form, all I do is distribute this 4 to each term here. So then I'm going to have y equals -4x plus 24, and then I subtract 2 from both sides. Because I have my positive 2 here, so I subtract it on both sides. Now I simplify, and I have -4x plus 22. And that is my equation in slope-intercept form. So this step right here, this is point slope form. And here we have slope-intercept form. Now I want to discuss the differences between parallel lines and perpendicular lines. So let's start with parallel lines. So as you know, parallel lines never intersect, and what's interesting about their slopes is the slopes are the same. So the slopes for parallel lines are the same. So for example, if we had an equation such as y equals 4x plus 7, the equation of a line that is parallel to that could be, for example, y equals 4x plus 12. Only difference would be that they have different y-intercepts, but they're never going to intersect because they rise 4 and they run 1. So they're never going to intersect with each other. Now, perpendicular lines are different. So perpendicular lines, they intersect to make a 90-degree angle, so their slopes can't be the same. Their slopes are actually opposite reciprocals of each other. So slopes are opposite reciprocals. So for example, if I had an equation with the slope of 3/2, and I wanted to find the equation of a line that was perpendicular to that, one example would be y equals -2/3. And it's okay if these have the same y-intercept as long as the slopes are opposite reciprocals. So let's do one more example. So let's say I had an equation with a line that had a slope of -5/7. Well, the opposite reciprocal of that would be +7/5. So you flip whatever you have and you make it the opposite. If it's negative, make it positive. If it's positive, you make it negative. So now let's write an equation in slope-intercept form for the line that passes through 5, -6 and is perpendicular to the line with equation y equals -3/2x plus 7. Alright, well, the first thing that we know that we can do is we can start off with our point-slope form. So y minus y1 equals m times x minus x1. So the two pieces of information that we need are the slope, and we need to know a point that this new line is going to go through, because we're not writing the equation for this line, obviously it's already written. We're writing the equation for a new line, one that's going to be perpendicular to that line through this point. Well, we figured out what our point's going to be for our new line. It's just going to be this 5, -6. So we can write this as y, not -6, but a +6 here. Our slope we still don't know, so we'll leave that blank. And then we'll have x minus 5. So now what we need to figure out is, what is our slope? Well, here's the key word to this entire problem: perpendicular. So if the first slope is -3/2, then the new slope, let's call it m2, call it m1. Our new slope is going to be the opposite reciprocal of -3/2, which is going to be 2/3. So our slope, we can put it in now as 2/3. So we have an equation now that's written in point-slope form that we need to turn into slope-intercept form. And we can do that by distributing that 2/3 here and then subtracting 6. So this is going to turn to 2/3 x minus 10/3, and then I'm going to subtract 6 from both sides. So I need to simplify my 10/3 minus 6 here. So that's going to be y equals 2/3 x minus 10/3. Now I want 6 to have a denominator of 3, so that'll have to be 18/3. And then my final answer will be y equals 2/3 x minus 28/3. So once again, we have our equation now in slope-intercept form down here, and up here it's in point-slope form. So let's just be mindful of what the directions of the problem are asking us for. So let's try a similar example, but now instead of writing the equation for a line that's perpendicular, let's write the equation for the line that's parallel. So we'll start off with our point-slope form. Y minus y1 equals m times x minus x1. And we know our point is 3, 7, so we can write y minus 7
equals m, we'll leave that blank for now, and our x1 is going to be 3. Now, our slope this time is just going to be 3 over 4 because it's parallel, so the slopes are the same. So we'll write 3 over 4 right there. Now, since we want this in slope-intercept form, we can distribute this 3 and isolate y. So we'll turn this into y equals 3/4 x minus 9 over 4, and then we'll add the 7 from the other side. Now I'll change my 7 to be something with a denominator 4. So I'll have y equals 3/4 x minus 9/4 plus, okay, I want a 4 in the denominator, so 7 times 4 will give me 28. So then I simplify, and I have y equals 3/4 x plus 19 over 4. So now I have an equation with a slope of 3/4 with a y-intercept of 19 over 4. That's going to be the end of our lesson for today. Good luck with the material, and take care.